board, thank you. All right, here we go. So, what I want you to copy down on the board, you have this chart over here. I want you to copy down the chart, please. You got M, capital M, L. Okay, so capital, yep, I'll tell you. Very good question. What does that mean? Megaliters. It's over here on the side. You've got megaliters, kiloliters, liters, and then milliliters. So little m stands for milliliters, whilst the capital M refers to megaliters. Okay? Now, because we work in the metric system, we like to work in powers of 10. Okay, so in this case, each one is 1,000 difference. Okay, so it's 1,000 times. So 1,000 mils, listening, 1,000 mils make 1 liter. 1,000 liters make 1 kiloliter. 1,000 kiloliters make 1 megaliter. Okay, now the question I have for you, because we kind of use this interchangeably, but what is the difference between volume and capacity? If you were to describe it, what is the difference between capacity and volume? Let's go with Michael.
The volume is how much space it takes up, and capacity is how much it can hold.
Very good. And in this case here, listening, Lila, don't speak while someone else is speaking. Thank you. So, Michael said that volume is the space, okay? And we measure that with our metric system, meaning your cms, your meters, your kilometers. That's our metric system, right? When we're talking about volume, that's what we're measuring. Capacity, on the other hand, specifically deals with the volume or capacity or the space where it holds fluid and gas. So this is where when you're buying your milk carton or orange juice, they don't write cubic meters. They don't say, oh, we have 3 cubic centimeters. We say we have 2 liters, okay? Or we say we have 500 mils. When you buy your cans, they are measured in either liters, mils, kiloliters, or megaliters. Actually, you never see megaliters, but the point is in your measurement, we're using it differently now. So you're used to seeing something like, I'm just going to move it up. You're used to seeing km. So I'm going to write here km, meters, centimeters, and then millimeters. That's what you're used to seeing. This one specifically does with fluid or gas, and I want you to copy this down so that we can work on the next question. Okay, so the next question will get you to practice converting from milliliters to liters and then liters to kiloliters, but they will also get you to convert from here, so gas and fluid, into cubic kilometers, cubic meters, cubic centimeters, and cubic millimeters. So how do you do that? There is one of the facts that this is common here that a lot of people don't know. So here, when you say 1 mil, okay, so if you think about 1 milliliter, you know when you have your measuring cup and you fill in 1 milliliter, 1 milliliter is equivalent, if you took that liquid and you measured, you know those cubes that you had back in primary school where they had the units blocks, and then they had the tens blocks and the hundreds blocks, yeah? One of those cubes is 1 cubic centimeter. So when you write here, 1 cubic centimeter, that's how much 1 mil will fill. If you took 1 mil and you filled it up in a cup correctly and you poured into that little cube, that's how much it can hold. Okay, so they're saying here that 1 mil is equivalent to 1 cubic centimeter. So it means that if you look at a can, does anyone know what the volume or the fluid in a can of Coke is? They normally have the number on the bottom. 375. Someone's been very attentive with their Coke cans. Very good. 375 is your typical Coke can, and that's 375 mils. So if you wanted to convert that into a space, if you want to make a box and you wanted to make sure that when you pour it in, it's going to fit, you can actually calculate that. Sometimes you have, like 3 cartons of milk, and then you've got a box and you're like, oh, will that contain all of these milk? You can calculate that because the box is measured in the metric system. This is measured in the fluid system. But you can convert between and you can figure it out. So 1 liter box. Why do they call it 1 liter box? Is because they don't want to make it confusing for people. So they keep it in fluid sets. But technically, any box, you can measure the length, measure the width, measure the height, and figure out the volume. But in the general public, people may not know 1 mil is equivalent to 1 cubic centimeter. But if you did know that, you can make your own box to make sure that you can take in whatever gas or fluid that you're trying to fill up. You can figure that out. And that also means you don't have to have a box. You can even design your own cylinder later on. You might want to make a compost bin, and it's a cylindrical shape. You can work out the volume in metric system and then convert that into liquid system or fluid system. And then you can say, yep, I just need this amount of fluid and that should last me X amount of days. So you can go between the two. That's the difference between the two. One is the metric system you're used to using a ruler to measure. The other is the fluid. So that's the one where if you're buying water or something like that online, or you go into a supermarket or Bunnings, that's what you're doing to measure the difference between the two. That's how you convert between the two. Okay, so sometimes when I buy lollies and they tell you, the amount of grams they have, I can estimate how much volume or capacity this thing has. And I look at my box and go, well, how many can I realistically fit in here? And I look at that volume and I kind of divide it and figure out what it is. But what I'm essentially doing is I'm converting from cubic centimeters, so the metric system, into the fluid system. And that's how I know how many lollies a box can fit, roughly. Okay, so you can do that, just the conversion. So today, you're going to start off with the first skill by copying the chart down and some of these common knowledge here. So this is meant to be common knowledge. Most people don't know them, but the first one is the most useful. Okay, because you can go from 1 mil, you can always get to 1 liter. Okay, so from 1 liter, which is this one, 1 liter to get to mils to 1 liter, we know that times by 1,000. Okay, so that's where this is coming from. And same thing. So these two, you don't really know. That one there, the first one, 1 mil is equivalent to 1 cubic centimeter, is very special. You can visualize that. 1 mil in a measuring cup, you can fill up one of those cubes that you used to have in primary school. Okay, that's how much water it can take. All right, now, let's do a practice question. How do we convert these? So you got your chart right there, and in your notes you should have the chart here as well. Let's do the first one here. A, you have 2 liters, and you want to convert this into milliliters. All right, so let's have a look. You've got 2 liters, so you're in the liter section. You're wanting to move it to milliliters. What do you have to do? Based on that chart, what do you have to do? Michael?
Times it by just 1 person.
Very good. It says here, moving from liters to mils, because we know that it takes 1,000 of these mils to make 1 liter. Now, if I've got 2 of these liters, then I would be multiplying 2 by 1,000. Whoops. By 1,000. 2 times 1,000, what is that equal to? What's 2 times 1,000, Logan? 2,000. Very good. So your answer is 2,000 milliliters. In your notes, this is how I want you to write it as well. So you got your question 3. It's exercise 4H. Some of you don't have your exercise, so I don't even know which questions you're doing. Make sure you have exercise 4H so I know which one you're doing. Question 3A, and I want you to write in this way so I know you're converting 2 liters into mils. There's a working solution to get your answer. AJ.
Can you go a tiny bit, please?
Yep. Like that? Cool. Yes, Michael.
Is that all you have to do without working out? Just show 2 liters equals millimeters and then just we don't need to do working out.
No, that's fine. Yeah. Because you have a calculator. You should have a calculator. That's another question. I expect everyone to have a calculator, physical one. I know some of you are using the laptop, but it would be good if you had the physical one because you've got to get practicing using the fraction notation. You got to get used to using brackets. Use the calculator if you have a physical one. Okay? Let's do another one. Let's try to do a conversion from liters, so fluid system, into cubic system. Let's do G, and I'll do a decimal one because sometimes decimal gets students here. But let's do C, 0.5 megaliters is equivalent to what in kiloliters? And then we have G. I'm just going to move up a bit. G, 2,500 cubic centimeters is equivalent to what in liters? Okay, so I'm going to zoom out so you can see the questions a bit better. Here we go. So again, we want to go from megaliters for the first question, 0.5 megaliters into kiloliters. Megaliters into kiloliters. What do I have to do? Let's go with Luke. Based on the diagram, to convert from megaliters to kiloliters, times by 1,000. Very good. I'm timesing by 1,000, so I want you to write times 1,000. Now here's a tricky question, or not tricky, but I'm interested in knowing, what is 0.5 times 1,000? What's 0.5 times 1,000? Go writer. 500. Another way, if you were confused with the decimal, 0.5 is half. If I said, what's half of 1,000? You would have picked that up as 500. Okay, so this is 500 kiloliters. Very good. What about now? So we're going to have to use one of the common properties over here. I want to convert cubic centimeters. Okay, so this is a metric measurement, and I want to convert it to a fluid system. I want to know how many liters there are. Now, it takes probably 2 steps to get to this. What are you going to do? What do you have to first do? So cubic centimeters, you got 2,500 cubic centimeters. Very good. And we know from here, this is a 1-to-1. 1 mil is equivalent to 1 cubic centimeter. So if I have 2,500 cubic centimeters, how many mils is that? Very good, Ryder. So we now know this is 2,500 milliliters. And then we can then go back to our fluid system and say, all right, well, I've got 2,500 mils, but I want to move it to liters. Very good. So here I'm going to be dividing by 1,000. And what is 2,500 divided by 1,000? Let's go with AJ.
25.
Ooh, very close. How do we divide by 1,000 again? What do we do? 2.5. Very good. Because there are 3 multiples of 10 there. So we're dividing it by 10 3 times. So we're moving decimal point back to the left 3 times. It goes here. That's 250. Do another one. That's 25. And another third one. That's now 2.5. So it is 2.5 liters. Okay, so there were 2 steps there. And that relied on the fact that you knew 1 mil is equivalent to 1 cubic centimeter. Okay, so that's your first skill. Okay, first skill is conversion. How do we feel? Pretty good? Very good. Last one. Now this is going back to primary school. We're starting off with some basic shapes. And the first shape that you learned in primary school to find volume. Anyone remember what the volume formula was? Very good. Length times width times height, or length times height times width, same thing. This is the first time that you learnt volume in primary school, and it's most likely most students will know that. Okay? But I want to highlight a small idea, and that will lead into the next exercise. I do want you to write on the bottom that the general formula for a volume is actually area times by its height. Okay? Now, volume only works with 3-dimensional shapes. Okay? Area works with what dimensional shape? 2. Okay? And then you have length, which is only 1 dimension. Right? When you have an area, see, why am I saying it's area times height? Volume formula actually comes from the idea that you find the area first. So this is the area I'm looking for. Notice that you're just doing length times width. This is your length. This is your width. You're just finding the area, which is a 2D shape. To make it 3D, you need to include a 3rd dimension. This is your 3rd dimension. The height. Right here, that's your height. That's the 3rd dimension. You had the length on one plane, you had the width on another plane, and then you had a perpendicular one where it goes up, or at least out of the page. So if you think about it, this is 2D, 1 length, 1 width, but to make it 3D, I would need this leg. Without this leg, it's just a 2D shape. But with that leg that goes perpendicular to that, that is now 3D. Okay, so that's why you need 3 different lengths in different directions, but they're all perpendicular with each other. See, the length and width are perpendicular, it's 90 degrees, and then the height is also 90 degrees. So that's a 3D shape. So what you're doing here is you're multiplying 3 different dimensions. You went from area, length times width is an area, times by the height gives you the 3rd dimension. The reason why I emphasize this is because you're going to move away from just rectangular prisms. You can do, circles is what you've learnt so far. But you can change a 2D shape, a circle, into a 3D. See, if I add a circle with a length, this now becomes what shape? Cylinder. So if you know how to find the area, which is the 2D, and then you multiply by the 3D or the 3rd dimension, you get a volume of the cylinder. Okay, so that's the idea. It's area by the 3rd dimension. But in primary school, they wouldn't have taught you that. They just simply said length by width by height. But that's the idea. You're doing 2-dimension and then a 3rd dimension. That's why it's always a 3D shape, volume. Okay? So today's lesson, that's all we're going to do. So we're going to do length times width times height. We've got our length, we've got our width, and our 3rd dimension is 2. So together, my volume is equal to 6 by 4 by 2. So let's do our multiplications here. 6 times 4. What is 6 times 4? Let's go with James. 24. Very good. 24, and then you got times 2. What is 24 times 2? Let's go with Luca.
24 times 2?
Yeah. 48. Very good. So this is how I want you to lay it out. See how I've got volume? That's my formula. Here I've substituted numbers in, my working solution and my answer, but I'm not done. What am I missing? What am I missing? The unit, the metric. Okay, and this is volume. So you write meters, but what do you have to include? Cubed. Very good, because this is volume. So volume is 3 dimensions. That's why we have a cube there. Area is 2 dimensions. That's why you have a square. And then perimeter, which is length, 1 dimension. You don't have a square or a cube. Okay? This is how I want you to lay out your working solution. Have the diagram, question, which is the reproach, method, answer. That's what I'm looking for. Okay? So you've seen samples before of what I want to see. Some of the great students around here, how the layout is so consistent, and so many people have improved. Okay? You can do it too. Everyone's done it. You've done it somewhere along this year. I've seen it. Okay? But that's what I want to see. That's how I want to see your working solution. Okay? So you have your time now. So we know where the questions are. It's all in one note. These are your questions to do. 2 skills. Find the volume and then conversion of capacity. So fluid to volume. Okay? So here are the questions, and I'm going to stop the video so you can rewatch if you like. Give me a second. Hoo-yah. And Diego, do you have any maths background?
Not really.
Oh, sorry. I was going to say you can come around and help any students too if you like. All good. Welcome, Diego. Let's stop the video.